exponential growth and decay. There's going to be a total of 4 formulas that you're going to have to be aware of. These two down here, and these are the two that you would use if you're dealing with a scientific situation. When you're dealing with a scientific situation, you want to use the one with the natural number e in it. If it's an exponential growth where things are increasing, you use the one where the k is positive. If it's an exponential decay, then you use the one where the exponent here is negative. You also have your non-scientific ones up here. You still have a growth and a decay situation. For the decay, you are subtracting your r. For growth, you are adding your r. In all of these, your a is your initial amount. Your t is your time in years. And your k here depends upon the situation you're dealing with. If you're dealing with carbon-14 half-life, then the value of k is this. The book doesn't give that to you, but I'm giving it to you here. Also, on the top two, the r up here is your percent of increase for this one over here, or your percent of decrease. So let's go ahead and take a look at this one here. Read through it, and then we'll go with this. Now, since we're really not dealing with a lot of chemicals and a lot of science stuff, it's not a scientific one, so we're going to use the other one. Also, the amount of caffeine in your body is slowly eliminated, slowly disappears out of your body, so it's a decay. So that's why we have this formula right here. A is going to be the initial amount that you start with. R is the rate of decay. What percent is leaving. And then t is how long. And you'll notice we're looking for how long, so you know we're going to try to be finding what t is. So in other words, we need to be able to know what those other three are. So we're looking for t. Your rate is 11%, so you write 11% as a decimal. Make sure you change it. You're starting out with 130 milligrams. But what is y? Well, it says how long will it take for 90% to be eliminated? Well, if 90% is eliminated, that means 10% is left in your body. Well, if you started out with 130, 10% of 130 is only 13 milligrams. So you're going to be left with your final amount, 13 milligrams. So now we need to go ahead and solve this. You'll notice we can work together the parentheses, and we want to try to get this part here with the exponent by itself. So in other words, you need to get rid of multiplying by 130. So to divide both sides by 130, and 13 divided by 130, that's where the 0.1 comes from. Once you have the part right here with the exponent by itself, you want to use logarithms. Since we're not dealing with a natural number e, I'm not going to use a natural logarithm. I'm going to apply just a common logarithm to both sides. Now, once again, when you have a variable as an exponent after a log, we can take this right here and put it down in front. Now we just have your variable multiplied by something. To get rid of multiplying by this, all we'd have to do is just divide both sides by the log of 0.89. Divide both sides with the log of 0.89, we would get this here. This is your calculator ready form, so you type it into your calculator, and you would get this. Really close to 20, but 20 what? We're dealing with time. Up here, our time is in hours. And I see I have a typo. We knew the units was hours because it says hours in our problem, so it would be after 20 hours. So you now need to look through this one here. Here you're dealing with the half-life of sodium-22. Well, to me, they're kind of dealing with science and chemical stuff. This is a scientific situation. When you're talking about a half-life, that's always a decay because half-life is how long it takes for a substance to only have half the material left. So here you're told that you need to try to find the value of K for sodium 22. So we have our natural number E. We have a time, your T here, we have a time. Now, we're trying to find K. We're trying to find this. So that must mean that we should be able to put something here and put something here. Well, what percent did you actually start out with? You started out with 100%, which you know is just 1. What are you ending up with? That's your Y. Well, you're ending up with, it says half, so that's 50% or 0.5. So that's what we're going to be plugging in here. Now, we don't really need to have the 1 here because 1 times this doesn't change it. Now, to solve this, I'm going to use natural logarithms because we're dealing with an e, and natural logarithms undo an e. So take a natural logarithm of both sides. Remember, when you do the natural log of the right side, that your e and your natural log undo each other, leaving you only with that exponent, and that's what we have here. Now, to finish getting k by itself, you got to get rid of the multiplying by negative 2.6. So you could divide both sides by it or multiply by the reciprocal. This is your calculator ready form. You type it into your calculator and we would get this. Now the value of k has no units, so we don't have to worry about putting appropriate units here, like we did in the last problem. So read through this one here. Now, how long ago did the mammoth die? How long ago? That's what we're looking for is t. So we should know and be able to plug stuff in for everything else. Remembering that e is the natural number e. Well, as we look here, it says 3%. Well, we have only 3% left, so we know we're going to have 3% here equaling. Well, what percent did the animal start out with? Well, he had it all, so that's 100%. And 100% as a decimal is 1. When you're dealing with carbon-14, remember from our first slide here that carbon-14 half-life is this number right here. So that's why we plug that in for K. Well, we don't really need to have the 1 here, so that disappears. So now we need to go ahead and get rid of, or get our exponent out of the logarithm. Sorry about that. We need to get our exponent out of the exponent, or variable out of the exponent, if I can talk here. Sorry about that. So we're going to go ahead and take the natural log of the left side, natural log of the right side. Natural log because we're dealing with the natural number e. Natural log of the left side. Take the natural log of the right side. Remember, when you take the natural log of an e, that it undoes the e and your natural log undo each other, leaving you only with your exponent. So that's why we just have this. So now you got to get rid of that by dividing both sides by this number to get t by itself. So that's your calculator ready form. You type it in and we would get this for our time. We know that we're going to have years here based on our problem because we're not dealing with hours and seconds for how old this is. And the carbon or half-life of carbon-14 is always measured in years. So here we're dealing with a city and it's growing at 3% a year. We're not really dealing with chemicals and all that stuff, so it's non-scientific, so that's why we have this. It's growing, so that's why we have a plus R, because it's your growth. So it's 3% a year, so we know that our R is going to be a 0.03, because remember you got to change your percent into a decimal. We're starting out with 1,000,000. We want to know when it's going to double, meaning get to 2,000,000. So A is your million, your initial amount. Y is your final amount. Well, it's got to be double a million, so that's why we have 2 million. Plugging in your R, we're going to find T. We knew we were trying to find T because it said how many years, and that's time. So you want to try to get the part that has your exponent on it by itself. So you got to get rid of that million, so you can divide both sides by a million. So you get 2 is equal to, and your parentheses simplify down to this. Now, to get our exponent out of, variable out of the exponent, we're going to use logarithms. But I'm not going to use a natural logarithm because I don't have an e here. I'm going to just use a common logarithm. Take a common log of the left, common log of the right. Once again, when you have a variable after your log, you can take that, put it down in front. And so you get t times something. To undo timesing by this log, all you'd have to do is go ahead and divide both sides. This is your calculator ready form. Then all we have to do is type that into our calculator, and we would get this. We know it's years because it says per year up here.